a block of mass m is tied using a thread to a cylinder of mass M and radius M. Let us assume that the tension in the string is T and that the acceleration of the smaller mass is A. Since there is no slipping at this point, we can write that R into the angular acceleration of the cylinder should be equal to the acceleration. First, we can write the Newton's equation for the smaller mass. We can write it as mg minus T is equal to ma. Here, to find out the tension, we use the equations of motion for this larger mass, that is the cylinder. For the cylinder, if we take a closer look at it, this is the tension and this is the distance. So here I can write that the tension multiplied by the distance at which the tension is being applied will be equal to I alpha, where I is the moment of inertia. Because it is given that it is a cylinder, we can take the moment of inertia of this body as mr square by 2 into alpha. Upon cancelling this and writing r alpha is equal to a from equation 1, we get T is equal to capital M by 2 into A. Substituting the value of T in equation 3, we get mg minus ma by 2 is equal to small m into A. From this, I can infer that mg should be equal to m by 2 plus m times A. From this, I can also infer that the acceleration of this body will be equal to m upon m by 2 plus small m times g, which can also be written as A is equal to m 2m upon capital M plus 2 times small m times g. Since we know the acceleration of the body and we are required to find the angular velocity of the cylinder as a function of time, we write omega is equal to A by R into T. Here T doesn't represent tension, T represents time. So here I can write omega as 2m upon m plus 2 times small m into g by r whole multiplied by t. So this will give us the solution for the angular velocity of the body.